Hey everyone, thanks so much for coming. Before I get started, just a quick round of applause for everyone who's doing such hard work. You may not know it, but there's a couple people in the back there doing all this video stuff, a handful of people in the back there, making sure everything's working, all the people who put in a hard time. So just a round of applause. Cool. So howdy. This is, I usually start every presentation with this, and usually I have a screen behind me, so it's a little easier, but I'll do this from the corner. And I'll try not to skip it. But I usually just like turn my back to the audience, I look at this, I put up my hands. I just do this and it calms me. And then you laugh and I no longer feel nervous. And then when you stop laughing, I'll stop. All right, cool, we're good. So, as I said, I'm Myles. I work at a small disruptive startup called IBM, contributing to a project called Node.js, many of you are familiar with. The opinions in this talk are my own, just throwing that out there. So, versions, how do they work? So versions, they're a lot like magnets, and stick with me on this. Versions are a lot like magnets, primarily that many people are pretty confused about how they work. But this stuff is really complicated. There's a lot of moving parts. There's a lot of different things going on. But something that's important to remember is that you don't actually need to understand everything to contribute in a meaningful way. By just knowing a small part of the process, you can contribute in a meaningful way. You don't need to know how the whole Node.js repo works in order to send an update to tests. And you don't need to know what every single commit does in order to make a release. So, we're going to start from a small piece, and we're going to build it up and see how we get into a more complicated system. So, we're going to start with Semver. Can I just see a quick raise of hands? How many people in the audience have heard of Semver before? And so keep your hands up if you use Semver in the projects that you manage. And keep your hands up if you 100% know exactly what Semver means to the spec. Cool. So, semantic versioning. As you see here, 3 digits. This is how we number software. The first digit is the major number, the middle digit is the minor number, and the last digit is the patch. A great way of thinking about what Semver is it's a contract. It's a contract between you as the developer and the people who are using your code. Now, you can go and change the versions of your software and have it not mean anything. Lots of people do that and they just tick the number every time or make the digits the date. But what's important about Semver is it's a contract of letting people know when you're going to break their code or when they can expect changes and what that means. So let's dig into each of these and talk about what they mean. So a patch. What is a patch? A patch is any change that does not change functionality, does not change behavior. I guess maybe functionality is not the right word to use. Let's stick to behavior. A patch is something that does not change behavior. It does not add new functionality. So this can be an update to a test. This could be an update to documentation. This could be a performance improvement. This could be tooling changes. This could be a new tap output. There's all sorts of things that can come in as a Semver patch as long as it's not changing the behavior and it's not changing and adding new features. And if you see a release come out that's just a patch release, just updating that last digit, you should generally expect that there are not going to be changes in behavior and new stuff, and you can just update it accordingly. This is part of the reason why we glob an NPM, so that we automatically get updates when we do an NPM install and don't lock to specific versions. One other thing that can come in as a patch, which is really important, are any sort of security changes. This is really important if the security changes are not changing anything. You can rely on a patch, generally making your code more reliable and faster. What's a minor? So a minor is any change that adds new functionality without changing behavior. So for example, the V8 inspector coming into Node could be considered a Semver minor improvement. If it didn't change any of the interfaces for the already existing debugger, and it's solely a new feature, you can bring it in. Other examples of things that can come in as minors are, new methods on a class, as long as they're not changing the native layer where any ABI changes are considered Semver major. Another example of something Semver minor could be enhancements of whole new modules or whole new interfaces that are introduced into the code. As long as what you're introducing doesn't change the behavior of the things that already exist, it can come in as a Semver minor. Finally, we have a major. An assembler major is anything that changes expected behavior. And there are things that can come in as semver major that you may not expect to be semver major. And a great example of this in Node are error messages. So right now, we consider any change to an error message in Node to be a semver major change, because individuals like yourselves may be relying on those messages in code paths, where a change to a message could result in all sorts of catastrophic errors. So when we introduced the new real path implementation in version 6, for example, part of the reason why we ended up reverting it was because it introduced potentially new throwing errors, which in turn then broke Node glob. And come and grab me afterwards if you want to hear more about how that turtled all the way down. But it's really important to make sure that we're not changing that contract. James Snell, who just gave a talk earlier on the HTTP2 interface, is doing some research right now into how we could modify error messages to actually have it be a lookup table, so that the text of the error message itself would be separated from the error code of the error message. And then we would be able to change the error messages themselves without actually causing any changes to code paths. This would be particularly interesting for it would allow us to do internationalization of error messages, which I think would be really, really cool. So, Node has a number of different release lines. Our current release line is v7.2.0. We have active LTS, which is v6.9.1 and v4.6.2. And maintenance LTS is 0.12.17. What you're going to notice is Node 10 is no longer maintained. For better or for worse, we are no longer maintaining it. And v0.12 is going to be end of life December 31st. It's time to upgrade if you're still running on either of these versions. One of the primary reasons why we decided to deprecate them was due to OpenSSL no longer maintaining the version of OpenSSL that's depended on in those versions. But also, the delta between 0, 10, and 12 and what we have going on in 4 and higher is so huge, it's actually a pretty non-trivial maintenance burden on the project to maintain those two versions. But so I talked about version 4, and I talked about versions 10 and 12. But you know, what happened with 1 through 3? And you know, what is the deal with 12? So Node started with an alternating release schedule. So even was stable, and odd was unstable. So I started using Node in 0.6, and when I started using it, 0.6 was the stable branch, and 0.7 was the unstable branch. New features and new experiments would land in 0.7, and 0.6 was treated as, you know, holy. And when it was ready for a major update, they bumped 0.7 to 0.8, and then started 9 as essentially the dev branch. Now, this is a system that works, but there's a couple problems with this. One of them is the lack of the granularity of the major version number. So by Semver's rules, if you do not have a Semver major number, and it's 0, then you actually just shift everything over. And the Semver minor reflects Semver major, and the Semver patch reflects Semver minor, and then patches are just out the window and they come as Semver minor releases. You know, for a project that's early, such as Node when it was starting, that kind of granularity may not exactly be necessary. But it can create this problem, this kind of like, when do we go 1.0 problem? Personally, I start all my projects now at 1.0, and the reason for that is that I don't want to ever start having that debate of like, are we stable enough to go to 1? And like, you create this really problematic narrative when you kind of have that first 0 there. And that's one of the things that was a problem. It was taking a really long time for 0.12 to come out. 0.10, I think, was the main stable branch for at least 2 years. Correct me afterwards if I was wrong on that. But it was taking a long time to move to 12, and it wasn't really clear when version 1 was even going to come out. So the project was forked in December of 2014. It's pretty amazing to think that it's almost 2 years ago now. That's, wow. But it was released as version 1, and this is particularly interesting because it's actually an appropriate use of Semver. The project was forked, Semver major change, you know? So they bumped to 1, and the project started moving forward using Semver proper. So v0.12 was released in February of 2015, just before Node Summit. It primarily included a small update to v8. The version of v8 that 0.10 was running on was another reason for the fork. People were just not happy running on an old version of v8. So v12 was released with a slightly updated version of v8 and also a handful of internationalization updates. But it did not include any of the work that was going on in I/O at the time. So during this time, versions 1 through 3 were all part of the IO.js project. If I recall correctly, and if you find Jeremiah out there, fishrock123 on GitHub, who's at the conference, their release process at the time was kind of just cut whatever is in master. So if we've got Semver major changes on master, then we cut a Semver major. If we've got minor changes, we cut a Semver minor. And some of that ethos still lives on in our current release cycle, which we'll talk about in a second. So Node was put into a foundation, the Node Foundation, which is the foundation behind this event. And the projects were merged as version 4.0 in September of 2015. 4.0 being the first version that had LTS support, which we can see here. This is our LTS release schedule. You can see that in October of 2016, v0.10 ended its maintenance cycle, and 0.12 ended its maintenance cycle in December. These two are special cases and not part of the new release process that we have that offers a 30-month LTS support cycle. LTS being short for long-term support. So this is part of a greater contract that we have to users to say, hey, if you're going to build and put code on Node, we can guarantee you support for the version of Node that your code is running on for essentially 3 years. You have 6 months of a branch being used as current, and if it's an even numbered branch, it's then going to have a 30-month LTS support cycle, 18 months as active and 12 months as maintenance. Our odd-numbered releases, you'll see, have a 6-month support cycle, and then there's like a small maintenance period afterwards where if there's any really big problems, we will do new updates. But the big change here is that we have this cycle that guarantees that we're moving forward with Semver major changes. There's no waiting for some esoteric thing to happen before we can move forward. And this gives us a really good way to schedule and plan changes that are coming and to really think about it. So an uneven release, such as 7, is a great place where we can put changes that are potentially more disruptive, because we can revert them in 7. And then by the time we get to 8, if the revert's a Semver major, that will never make it into LTS. So this gives us a bit of granularity, and in a year, we're going to have 2 different major versions, or I mean, technically 3 if you're thinking about the bookend. But this gives us a really great granularity on how we do releases, how we think about things landing, and how we can guarantee that we're not breaking stuff for people. So what's a current release line? The current release line is the main release line that we use for all versions. Anything that lands on master that isn't Semver major gets cut into a current release on a weekly or bi-weekly basis, depending on how many commits are in there. I had mentioned active LTS. So the main thing that makes active LTS a special process is that we work as hard as possible to backport all commits that are in active LTS quickly, to keep the delta between master and the LTS branches as small as possible. But there's only certain things that we backport. We'll backport perf improvements as long as they've lived for a long time in a release without any problems. We'll backport test changes, doc fixes, security patches. Primarily anything that's going to improve Node without causing any regressions or problems for our users. The primary thing that we think about with active LTS is that we do not allow anything to land into active LTS that has not lived in a current release for at least 2 weeks, and longer for more controversial changes. Maintenance LTS, on the other hand, no longer has that active backporting of things from new releases, but we will continue to support it during the maintenance period with any major security vulnerabilities or any major regressions that are found. So, if it's 3 months after it's moved into maintenance and we find a huge bug, we're going to do a release. At any time that there's like an OpenSSL CVE or some sort of V8 change, we're going to continue to backport that, during that whole 30-month cycle. So for reference, version 4 is about 13 months into its LTS cycle. So it has another 5 months before it's going to finish being an active LTS and moved into maintenance mode. What about master? Pretty much every pull request that comes in lands directly into master. We do not maintain a dev branch. What we do is we have master and we cherry pick and backport commits directly from master to all of the release lines. So how do we manage all of this? Mostly magic. More specifically, Git magic. We use a lot of different Git tooling to manage this in scripts. And what I find particularly cool about Git magic is since it's magic with trees, basically makes us elves. But so we maintain release branches. We have a release branch for the 12, 4, 6, and 7. These are all branches that live in our repo. We also have staging branches. And each of these staging branches, we put commits on before we're going to do a release that we know that we want to have landed in those releases. Most changes, as I said, have to live in a release for at least 2 weeks before they're put into any of the LTS staging branches. So let's do a little demo. So let's look at the node repo here. And let's look at our pull request. And I'm going to show you a little bit of what the process of backporting something looks like. So if we go here to labels, and we can look at LTS watch v6. And if we go to closed, here are all of the pull requests that have landed onto master that have not yet been backported to an LTS release. And so I'm going to pick, a random commit that I definitely have not reviewed before and made sure that it's going to work. We'll take this one right here. Now this one's a little new. It started on October 5th, but it only landed 2 days ago. But what I think is important about here is to actually look at the changes, and this is something we'll think about. Well, it's actually mostly updating vars to consts and changing equal to strict equal. And that's really all it's doing, and it's all inside of the test suite. So none of this is affecting the performance of the project itself. This is just stuff that's going to make our CI better. So what we can do is we can go and we can take the commit, and we can take a look at it. Here's the commit that came in. A little fun thing on GitHub that you may not know about is if you add .patch to the end of any commit, it's going to give you a git mail message, which is the way in which the kernel maintainers originally handed patches around. It will allow you to patch directly onto the head of a branch, not cause any weird branching, and makes it really great for bisect. And git bisect is kind of the best thing that ever happened to computers, in my opinion. So what we can do is we can hop here into the staging branch. I can call patch it, which is a little alias that I have for a handful of git commands. It's going to curl this this line, adding .patch to the end, and then it's going to pipe that to git am. And now we can see in TIG that that change is indeed there. We can see it has what we expect. We can go and we can grab the path to that test, and we can quickly run the test. The test works. And we update upstream. We can go back into this thing, and we can remove the LTS watch label from v6 and say that it was landed. So one of the things that's cool that's happening now is we actually have 2 LTS releases that we're managing at the same time, and it turns out that it doesn't actually take twice as much time to do it. So now we've got this. I can just go here, grab that same Python command that I had just used, just copy it, paste it, worked, push upstream. We just updated v4. So now we've gone through and we've audited this commit. We've landed the commits into our staging branches for both of those LTS releases. And not the next LTS release, which is currently in a release candidacy, but in a following LTS release, that update to the test will make its way into the project. When we do this, we have a backlog of between 300 and 500 commits in a month that we need to do this with. But we're constantly going through. That was an example of one that's really easy to audit and make the decision to backport, but sometimes when things are a little bit more complicated, we bring in other individuals to help us with it. So when we're ready for a release, we branch off of one of the release branches. Those release branches are sacred. We do not force push to them. We do not modify them. They are only updated by the releases, and the head of it will always be the head of the last release of that release line. So we branch off of it, and then we cherry pick all the commits from staging that we want to have in that release. How do we know which commits to cherry pick? GitHub labels. So we have a GitHub label for Semver Major, for Semver Minor, for LTS Watch, and for Don't Land. All those different labels that you saw going on. And then we have tools. Tools such as branch diff. So if you're doing a git diff is actually going to be comparing the 2 trees and letting you know what the difference is in the file system of those trees. That's not what we want to know when we're doing backports for LTS. What we care about for backports of LTS are atomic units of change. We care that this specific change with this specific title and metadata exists on the other branch. It may touch completely different code, and it may do things slightly differently. So with branch diff, what we can do is branch diff will go, it will compare the titles of the commits, the metadata of the commits, and then give us a list of commits which don't exist on that branch. So, for example, we can go here into v6, and we can say, So we can do a branch diff, and we can say, hey, from v6 staging to master. And this is going to take a second, but it's going to go through and it's going to give us a list of all the commits that exist on master that don't exist on v6 staging. And so all these green ones that you can see here are all the Semver major changes. So we can add a number of filters to say, hey, we don't care about any commit that is Semver major. We don't care about any commit that has a label for LTS already. And we don't care, and we can just keep adding labels like to filter out the release commits. And eventually you can go and start making these audit lists, and we can see right here the last audit list for v6. These are all commits that have not yet been labeled and need to be audited. We'll wait a couple weeks because we caught up to where the latest release was for v7. So once the next v7 release comes out, we'll start auditing again and catching up. So we have changelog maker as well, which is built on branch diff, and that automates the changelog process. And we have a number of scripts that we use for releases as well. So I'm going to have to go through this really quickly because I'm running out of time, but what's a breaking change when we talk about Semver major? And I love this GIF. I really hope no one got hurt, though. But so a Semver major change is any breaking change, any behavior change, as we were talking. And there's ways to avoid these breaking changes. The number one that you can think of is CI. But another thing that we do is what's known as smoke testing. And we have a utility called Canary in the Goldmine. Canary in the Goldmine will grab the test suites and tarballs of the top 70 modules in the ecosystem. It will run all the tests, and then it will report breakages. This is an example of where we've seen breakages. A breakage on Jade and a breakage on Body Parser. Turned out Jade had to change their name to Pug. I'm kind of bitter about that. But they didn't update their package JSON, so our algorithm for resolving tarballs is broken. So we sent a quick pull request, and it was updated. The change to Body Parser was a little worse. Body Parser is built on top of query string, and it's used inside of Express for pretty much any body that you're parsing. So this is code that's really, really hot. And there was an optimization here on split. Basically, every time that split was called, we were calling split, and then we were doing a comparison for max length and then shortening the string. This wasn't super optimized. This creates lots of extra garbage. It's not the best thing to do. So all we did is we realized you can pass an argument of max keys to split, and then that can all be handled in V8 land. What they didn't account for was infinity, because it turns out that split actually infers infinity to an integer, and when infinity is inferred to an integer, it's 0. So before the change, you would get a length of 1 for infinity. After the change, you'd get a length of 0. So what was really interesting here, we were not testing this edge case in Node, but Body Parser was. So when we broke Body Parser's test, we were able to go take that test, make it abstract enough that it was just for Node, move that test into Node, and make a fix, and it was like, one line. And the smoke testing saved the day. The thing that was the coolest is while the change was on master, it had not made it to a release, so it actually never ended up in user land, and we could land a fix before it even got out into the wild. Okay, so really quickly, what version should you use? V4 has had a while to stabilize on LTS, and V6 has been on LTS for about a month, and it's getting ready for its third release. And V7 is always getting the latest and greatest. So why use V4? Hardened by the ongoing LTS process, it is going to be, in my opinion, the most stable of all the releases that we have right now. So if you already have something working on 4, there's probably no reason to update it immediately. You may want to look into it because 4 is moving into maintenance in the next 6 months, but you're probably good. 6 has the longest support cycle of any of the LTS releases out there right now. So if you get onto 6, you're going to have a longer support cycle. It's the closest to master of all the LTS releases, which means it comes with V8 5.1, which is a much broader support for ES6 than what's on V4. It also has the inspector API, which is super rad. Do you have to use LTS? No, you're adults. You can do whatever you want. But it comes with V8 5.4, comes with a little bit of ES 2016. It's the latest and greatest. But if you use it in production, I'm going to be really, really scared. So yeah, if you're going to use V7 in production, just be prepared for breakages. Is kind of all that I can warn you. So anyways, thank you very much for the time. I'm Myles, and this is Surfing Pupper. Thank you.